Hello everybody, welcome back again. It's Mr. Anderson here with you for another exciting Algebra 2 lesson. We're in section 5.7, so we're going to talk about roots and zeros today in section 5.7. So let's get right to it and see what we can do. First of all, our objectives. Number one, we want to be able to determine the number and type of roots for a polynomial equation. So in other words, we'll solve it and see what kind of roots we get. And then number two, find all of the zeros of a polynomial function. So again, finding the zeros. All right, let's take a look here at all of this crazy stuff here. Basically, this isn't, it looks kind of like a lot of stuff to talk about here, but really this is pretty simple. This is the equation or the function that we're given right here, and of course this is our graph, and we're talking about roots, zeros, intercepts, and factors. And basically in this first step here, right here, they're saying, well, the zeros of this, remember the zeros are where the graph crosses the x-axis, so it would be like right here, 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 and here, right? Well, that's -3, -2, 1, and 2. So it's just saying the zeros of this function are those points. Well, secondly, the roots of this equation where it equals 0, it's the same equation here though, this is written in function form, it's the same numbers. So the roots and zeros are basically the same things. Jump down, we'll come back to factors, but then jump down to here, and the x-intercepts, remember the x-intercept is where the line or our graph crosses the x-axis, which are the same points except for if it's, talking about the x-intercept, instead of just giving the number like the 0 or the root, it's just the point. So notice you have -3 on both of these. Here it's -3, 0. That's the actual point. -2, 0, 1, 0, 2, 0. Notice how that all compares to -2, 1, and 2. It's all the same numbers, but when we're talking about the x-intercepts, that refers to the point, not just the number. Okay, so it's really pretty much the same stuff. The last thing here, which we'll come back to this at the end of the lesson here today, is this one. The factors of this polynomial are x plus 3, x plus 2, x minus 1, and x minus 2. Where did that come from? Well, remember when we would break down an equation, we'd factor it down into its parentheses. The last step would be if we had, if we broke it down to all these parentheses here, where it was equal to 0, then what we did was we found what does it take to make each parentheses equal 0. So what does it take to make x plus 3 equal 0? It has to be -3. What does it take to make x plus 2 equal 0? -2. What does it take to x minus 1 to be 0? +1. And what does it take x minus 2 to be 0? It takes a +2. So the factors, it's just kind of back up one step from your roots or your zeros here. And you notice basically when you put this back in its factor, you just have x and then it changes the sign. If this was -3, it would go to x plus 3 would be the factor. If this was a +2 here, its factor would be x minus 2. So when you put it into its factor, basically you're doing x and then either plus or minus that number. It's always going to change the sign there. So that's all that this is saying. All right. Another thing, really important thing to know about all this stuff is whatever your degree polynomial is, like here it's third degree polynomial because x to the third. Here it's a fourth degree polynomial. Here it's fifth. Whatever degree polynomial you have, that's how many roots you will have. So if you have x to the third power, if 3 is your biggest exponent, you'll have 3 roots. 4, x to the fourth power, you have 4 roots. Fifth power, 5 roots, and so forth. Now this includes real roots, which are what we can see on the graph where it crosses the x-axis, but it also includes imaginary roots. You won't see those on the graph if you graph it, but there will still be imaginary roots sometimes. And sometimes when you graph it, you might have, as they say here, a repeated root. A lot of times we see it as a double root, where basically you get the same answer twice. The same root comes up twice. So it's the same number, but it's really a double root because it comes up twice. So your number of roots will match your biggest exponent there. All right, so let's start out here. We're going to solve this equation, and then we're just going to say how many and what type of roots do we have. Okay, so you kind of have to think through a lot of different ways that we've solved equations before. First thing I would do here is when I'm looking at this, I see, well, it's a trinomial. So the first thing I'm going to think of trying is our standard trinomial factoring thing where we say what times what is negative 48 but adds up to be 2. And if you think, oh, well, that's going to be 8 and negative 6, then you are correct. Because 8 times negative 6 is negative 48, but 8 plus a negative 6 is 2. So what will happen is this will break down to x plus 8, x minus 6, and then remember what I was talking about with the factors. These are your two factors. And so to solve this, we have to figure out what does it take to make this equal 0. X would equal negative 8. And here x would equal 6. So here's our two solutions. So, and how many do we expect to get? X squared means we expect to get 2 roots. Did we get 2 roots? Yes, we did. So that's it. There's no more left hiding anywhere. We've got everything. So what kind of roots are these? Well, these we can see them on a graph. They're real numbers, so we call them real roots. So we would say we have 2 real roots. In that situation, we have 2 real roots. Okay? It's going to get a little harder. All right, how about this one? Now you look at this, you go, whoa, okay, well this is not a trinomial. I can't do it the same way I did before. But remember, there's always one thing that we always look for first. We always look for GCF, right? Well, if you take a look, you go, hey, they both have an x in common. Let's take out a GCF. So the GCF is x. We take out x. We have x squared plus 25 equals 0. Okay, so we've got to factor down a little bit. And you look at this, you might think, hey, x squared, that's a perfect square. 25 is a perfect square. But, uh-oh, it's not difference of squares. It's not subtraction. This is a plus 25, so we can't do this. We can't factor it down any further. So what I have to do is I have to go to kind of that other method that we talked about where I can't factor it any further, but I'm just going to go through and I'm going to say what's going to take to make each part equal 0. I'm just going to have to go through a few more steps here. Well, first of all, with this one right here, x would equal 0, right? Because 0 times this parentheses will equal 0. So we got 0 as one of our solutions. Now what can I do with this? Well, this is where, remember, we can say, well, what would it take to make x squared plus 25 equal 0? And then we can subtract 25. So I have x squared equals a negative 25. To undo square, we take the square root. Remember, when you take the square root of both sides, you always end up with a plus or a minus. And now 25 is a perfect square, but we got this negative in here. So remember, this is really, I'm just going to do a side arrow here. This is really like the square root of negative 1 times the square root of 25. And so what's the square root of negative 1? Did you say I? That is correct. So this is I, this becomes I, and the square root of 25 is 5. So in other words, 5i. So here's the rest of our roots. And actually, you know, notice we have plus or minus here. That means we have a positive 5i and a negative 5i. And then we also have a 0 over here. How many roots do we have? 1, 2, 3. Third power, 3 roots. Perfect, we got everything. So what do we have here? Well, 0 is a real number. So we're going to say, well, I have 1 real root. And because these have an I in them, that means they're imaginary. And so we would say we have 2 imaginary because of the plus and minus there. That's a positive and a negative, so that's why there's 2 there. Okay? Okay, so that was a little harder. All right, so now it's kind of a similar thing here, but there's going to be a part here in the homework that you'll do where they're going to ask you to find all the zeros of this. Okay, so it gets a little bit harder here maybe, but I'm going to show you kind of an easy way to do this. In the book, if you look in the book, they're going to tell you set this up with synthetic and pick some numbers and keep doing synthetic substitution until you find one where your remainder comes out to be 0. Remember how we've done that before? Because if we have a remainder of 0, that's a factor. Okay. Well, here's the easy way to do it. Remember our calculator? Bring on the calculator. Let me see here where I can put this. I think that'll be okay over there. So here's our calculator. Here's kind of an easy way to do this. Okay, first of all, we'll turn it on. Let's plug this in. You know, we hit our y equals button, plug it in. So I've got, why are you not working? It was working before. Golly. So irritating. Alright, so here we go. We got x raised to the 3rd power minus x squared plus 2x plus 4. So we type that in, go second function table. So let's look at our table. Okay, so what I'm looking for here, I'm looking for in the y column, I'm looking to find a 0. Because, and as a matter of fact, well, I guess I can't draw on the calculator here, but it's right here. So at this 0, that means, okay, that's a 0 or a root. Okay, so first of all, it's going to go away here again. So first of all, that means, what was it, a -1, I think, is one of our zeros. I'm going to try to get this back here. Yeah, bear with me. I'm still working on these things here. All right, so at the 0, -1 is our 0. Okay, when there's a 0 in y, -1 is what we call our 0. That's where it crosses the x-axis. And if you looked at the graph here, notice right there, that's where it crosses. That's at a -1. So that means that's going to be one of our roots. Now you notice you don't see it crossing anywhere else here, do you? But we have to have 3 roots because it's x to the 3rd. So you can guess that the other 2 roots are going to be imaginary. Okay? But let's start with this one. So let me go back to here. So we know that -1 is one of our roots. So what I'm going to do here then is I am going to do synthetic division or synthetic substitution, and -1 is going to go in the box, and I'm going to fill this out here. 1, -1, 2, 4. If I divide this out, I should come out with 0 as a remainder. So 1 times -1, -1, -2, +2, that gives me 4. 4 times -1 is -4, and 0, yes. So the remaining polynomial now, the depressed polynomial, is this here, which would be x squared minus 2x plus 4. So that's what's left. We took out this 0, divided that out. Here's what we've got left. Now, as you remember from our graph over here, it's not going to come back down and cross the x-axis anywhere else. So what's left will not factor down You can do try what you can to try to factor this down, but it won't go. So what you're going to have to do is the quadratic formula. Remember that? So we're going to do, remember x is equal to the opposite of b plus or minus the square root. All that. So that's what we're going to have to do. So remember, a here is 1, b is -2, and c is 4. Okay, go back, way back into your memory there. Remember when we did this. So we've got x is equal to the opposite of b, so that's +2, plus or minus the square root, b squared, that's -2 squared, which is 4, minus 4 times a, 1, times c, 4, all over 2a. So 2 times a, or 2 times 1 is 2. So we just have to simplify all this. Oh, I forgot a parentheses. So what we've got here is 2 plus or minus, what do we got here? Let's see, 4, looks like it's 4 minus 16. Square root of 4 minus 16, all over 2. 4 minus 16, that's going to be a -12, right? So we've got 2 plus or minus square root of -12 over 2. Because of the negative here, remember that's I. We can take out that -1 to make I. So let me kind of draw a squiggly line here. So we've got now 2 plus or minus, that's a plus or minus there, I square root of 12 over 2. Can we break down this 12 a little bit? Remember when we broke down square roots? We can think of that as square root of 4 times the square root of 3. So that would be 2 plus or minus I square root of 4 square root of 3 all over 2. Square root of 4 is 2. So this is going to be 2 plus or minus 2I square root of 3 all over 2. And then since both of these parts on both sides of the plus or minus, they both have a 2, that 2, each of those 2's can cancel out this 2 here. And so what we really end up with is 1 plus or minus I square root of 3. So our zeros were, remember our -1 that we found from the calculator, -1 was a 0, and then 1 plus I squared of 3 and 1 minus I squared of 3. That's our 3 zeros. Remember from our, here it is, from our biggest exponent there, that there's 3 there. So there's 1 and 2, 3. All right, let's do one more like that. You probably need to do another one of those. Okay, so again, go to the calculator, start at the calculator, y equals, let's type this in. Notice we're going to have 4 roots this time. So x raised to the 4th power minus 18x squared plus 12x, uh-oh, how'd that happen? 12x plus 80. Oops. 80. So second function table. All right, remember we're looking for a 0. Now here's the thing. Here's an interesting thing about this. Look, we got 2 zeros here. And if you look at the graph, you'll notice it crosses in 2 places here. So we're going to have 2 real zeros. There's no other places that it crosses here, so we're going to have 2 imaginary zeros. So we kind of know what we're looking for there. So let's go back to this table. You could start with either one, -4 or -2. Let's start with -2. We know -2. Actually, I'm just going to go ahead and write this up here. Oops. Ugh. There's -2. There's one of my roots. But let's do synthetic here. -2. And I've got 1. That's x to the 4th. There's no x to the 3rd, so I have to put in a 0. -18 for x squared, 12 for x, and 80. Remember, we should come out with 0 as our remainder. 1, -2, -2, 4. That's going to be -14. and then that's 28, I guess. And we add those, that's 40, and negative 80, so that's good. So negative 2 is one of our zeros. Now let's take the remaining polynomial. Remember, it was x to the fourth, so this is going to be x to the third. X to the third minus 2x minus 14 plus 40. And now you could type that new polynomial in and do the same thing and find the 0. But we know from doing this, the other 0 is at negative 4. So instead of typing this whole new thing in here again and finding negative 4 is going to be a 0, let's just use negative 4 right away here. So I'm going to use negative 4 this time, and I'm going to use the new polynomial. Okay, so it's going to be x to the third. Oops. Oh, I didn't even write this correctly here. X to the third, that's x squared, and this is x. Boy, that was bad. So this is going to be 1, negative 2, negative 14, and 40. And again, this should be 0 as our remainder. So 1 goes down here. 1 times negative 4. Add them, negative 6, 24, add those, 10, negative 40, and it is, that's good, yay. So what we've got left then is, since it was x to the third, it's now x squared minus 6x plus 10. Now we know that that should not break down any further because we didn't see any more zeros here. And if you try 1 times 10, 2 times 5, nothing will give me 6 or negative 6 when I try to factor this further. So I'm going to again use the quadratic formula. By the way, negative 4 was another root here, so I'm going to write that in up here as well. So far we have negative 4, negative 2 as our zeros. And then I have to do the quadratic formula one more time to find the remaining 2. And so in this situation, then we're going to go x is equal to the opposite of b, which is 6, plus or minus the square root of b squared, 36, minus 4a, which is 1, and c, 10, all over 2a. So all over 2. So let's see if we can't start working this out here a little bit. We've got 6 plus or minus 36 minus 40 is a negative 4. And remember, a negative, that brings out an I, and square root of 4 goes out evenly, right? So this is going to be 6 plus or minus 2i over 2. And again, both of these can divide evenly by 2, so we'll divide 6 divided by 2 and 2 divided by 2. So what we end up with here, which I'm going to move it up there, that's an arrow, by the way, will be 3, where's my, there it is, 3 plus or minus I. Okay, so 3 plus or minus I. So there's our four zeros, negative 4, negative 2, 3 plus I, and 3 minus I. There's our 4 zeros. Okay? Now here's another important thing once it stops spinning. Here's another important thing to know about imaginary roots and zeros. If you noticed, and I'll pop it back to show you in a second, but basically it says, hey, if you have 3 plus 4i is a 0, then 3 minus 4i is also going to be a 0. Those are, if you remember when we did this before, they're conjugates of each other. So basically, roots, imaginary roots and zeros always come in pairs. Okay, so you'll never have just one imaginary root. They'll always come in pairs. You know, it'll always be like this, 3 plus 4i, 3 minus 4i. If I go back to that previous problem, look at the imaginary roots there, 3 plus I and 3 minus I. Okay, so they always come in pairs like that. So that's important to keep in mind. And so when we do our last few problems here, now it's not going to come into play here, but the next couple it will. But remember way back at the beginning when I talked about factors? Well, what we're going to do in this kind of a problem, we're going to write a polynomial function where in integral coefficients just means they have integers for their coefficients. with the following zeros. So what I have to do is I have to write each one of these in its factor and then just multiply those factors back together. I think we've done something similar to this before. So the factor that 3 came from was x minus 3. The factor that negative 5 came from was x plus 5. And 1 came from x minus 1. So these three answers, or roots, or zeros, came from these three factors. So in order to get this back to the polynomial, we just multiply them together. There's 3 of them here. Just pick 2 of them and FOIL it. Then whatever's left, multiply it by the third one. So I'm going to do the first 2 here. So x times x, x squared, outside, 5x, inside, negative 3x, and last, negative 15. So when I combine these here, 5 minus 3 is 2x. So the first 2 I multiplied to get this trinomial. Now all I have to do is multiply it by that third one, x minus 1. And remember, you can just distribute the x to everything and the negative 1 to everything. So when I go x times x squared, that's x to the third. X times 2x is 2x squared. X times 15, negative 15x. Then negative 1 times x squared is negative x squared. Negative 1 times 2x is negative 2x. Negative 1 times negative 15 is plus 15. And so then we just combine our like terms. I've got x to the third. Here's my 2x squared minus x squared is 1x squared, so plus x squared. Use those. And then I've got negative 15x and a negative 2x, so that's a negative 17x. And then lastly 15, so plus 15 equals 0. So that would be the equation, or the polynomial, that came from. And as a matter of fact, they might even, let me see the way they give the answers here. Yeah, I think probably in the book the way they'll give this is they would say f of x equals this stuff. So they would give it that way since it's a function. Okay, so that's if you just have just regular real numbers. Okay, now it gets a little trickier. Notice we've got an I in there. We've got an imaginary number. So remember what we just said about the imaginary numbers, they always come in pairs. So if that means if negative 3i is one of the zeros, that positive 3i is also a 0. So we really have 4 zeros here. Okay, so let's write the factors that they come from. It's going to be x plus 2, x minus 5, then it's x minus a negative, so that's going to make this x plus 3i and x minus 3i. Because we just follow the same pattern. Remember, we change the sign here, change that sign here, change that sign to be plus, change the sign to be negative. And now we're going to multiply them together. Now this seems like a lot of stuff, but anytime that you can, that you have several imaginary numbers here, multiply those together, because their middle term is going to cancel out and make it a little bit easier. So let's do that first. X times x, x squared. That's going to be negative 3ix and plus 3ix. Do you see why that's good? Because those cancel out. And then finally minus 9i squared, because it's negative 3 times a positive 3 is negative 9, I times I is I squared. And then, remember when we did this before, I squared is negative 1. Remember that? So this is really a negative 1 times a negative 9, or in other words, plus 9. So when I've multiplied those two parentheses together, here's what I've got, another binomial. And that's a little easier than a trinomial here. Now I can multiply these two together. X squared minus 5x, that's this. This is going to give me plus 2x minus 10. And then when I combine the like terms here, x squared minus 3x minus 10. And then just like that last one, distribute the x squared and the 9 to each one of these. So x squared times x squared is x to the 4th, minus 3x to the 3rd, minus 10x squared. Then distribute the 9. That goes to the x squared there. So plus 9x squared, then 10 to the negative 3, so minus 27x, and then minus 90. Combine all like terms, x to the 4th. Here's an x minus x to the 3rd. There's no other x to the 3rd, so minus 3x to the 3rd. Couple of x squareds here, negative 10 plus 9, so that's minus x squared, minus 27x, minus 90. And again, I didn't leave room there, but the way the book writes that is, f of x equals all of that stuff. So there's your function, x to the 4th. And notice it's x to the 4th, and we had 4 roots. All right, last one. And this might be the hardest one here. But stick with me here. Okay, let's, first of all, we know if we have 4 minus I, we're also going to have 4 plus I. Okay, so we have 3 roots. That means we're going to have to end up with an x to the 3rd here. All right, so here's our factors, x minus 4. Then this one, remember how we did this before? We did minus x minus each one of these. We changed the sign basically. So here's why it's a little hard. So it's going to be like x minus 4 minus I. And actually, let me do this. Make these brackets. And x minus 4 plus I. Okay, that'll work. Because remember before on the last one, let me go back here. We, since it was all it was just negative 3i, we could just do plus 3i minus 3i. Well, here we have to do, minus this one and minus that one. If we've got a negative out in front, anytime we have a negative in front of the parentheses, what do we have to do? Distribute the negative. So what this is going to be here is x minus 4, negative times the negative is plus I. Same thing here, distribute the negative, so it's going to be x minus 4 minus I. Okay, like I said, this one's a little trickier. We still have the x plus 4, or x minus 4, sorry. Oh, hold on. Ink. Uh-oh. All right, I think I'm back. X minus 4. Now, there is a way that the book talks about doing this. Here's what I think is easier. Just treat these as 2 trinomials, and let's just multiply these 2 trinomials together. So distribute the x, distribute the negative 4, distribute the I. It's kind of a few more steps, but I think it's probably easier in the long run. So I'm going to go x times x, x squared. X times negative 4, negative 4x. X times I is a negative ix, or xi, whatever you want to call it. So I distributed the x. Now let's distribute the negative 4. Negative 4 times x, negative 4x, negative 4 times negative 4 is plus 16. Negative 4 times negative I is a positive 4i. Okay, then distribute the I here. So I times x is plus ix. I times negative 4, negative 4i. And I times negative I is a negative I squared. A lot of stuff there, but some of the stuff is going to cancel out, okay? So first of all, let's look through here. I've got negative ix right here and positive ix. Those cancel. Then I've got a positive 4i and a negative 4i. Those cancel. Then when I combine these here, I've got x squared, negative 4x, and negative 4x is negative 8x. So that takes care of those. And then I've got 16 here. And then what's I squared again? I squared is -1. So this is like minus a -1, which is plus 1. So this is like saying it's a plus 1. So 16 and 1 is 17. So when you multiply those two together, here's what you end up with. X squared minus 8x plus 17. Then the last step is, like we did before, we've got to multiply a binomial and a trinomial, and then we will be done. So x times x squared, x to the third, minus 8x squared, plus 17x, negative 4, x squared, plus 32x, and what's that going to be? Let's see. 4 times 17, 68. And so that'll be a negative 68. Combine the like terms. So x to the third, negative 8, negative 4 is minus 12x squared. 17 and 32 is 49x and minus 68. And again, I didn't leave enough room again, so f of x equals. So that would be your answer there as far as the polynomial function. Okay, kind of a lot of stuff there. You know, especially the last couple of problems there are a little tricky. We'll go over those more in class. But the main thing to keep in mind with these things here are that if you have an imaginary root, you have to have the conjugate of that imaginary root. You have to have both of them, and then when you turn it back into its function or its factor form, you just, you know, basically you're changing the signs there, because that's what, you know, with this one, change the sign from positive to negative. So that's what we're doing, minus that, which changes its signs, and then minus this one, which also changes its signs. So a little trickier on those, but we'll work on it. So anyway, that's it for section 5.7. Thanks for joining me. We'll see you next time on The Price is Right.